Welcome to the second week of the course Introduction to Climate Change Mitigation. Before we can start talking about mitigation of emissions, we first need to know how much we emit now. And that is strongly related to energy use. Therefore, this week we'll go into detail on how we measure energy and emissions. We will start now discussing energy use and how you measure it. In this video, we are going to introduce the important units of energy and some basic energy calculations. I hope by now you have watched the Energy Slaves video that was provided. If not, please watch that now. I think we can learn a number of things from this video. First of all, it is clear that we use an incredible amount of energy. In some cases there is a sharp peak in consumption during very short periods. Other forms of consumption are almost constant throughout the day in much smaller amounts. Together it is a lot, and because most of the final energy we use is still sourced from fossil fuels, we can say we have a lot of fossil energy slaves, just like the rowers in the video. What is also clear is that a lot of this energy consumption goes unnoticed. In some applications like lighting, it may be clear. However, for many other daily tasks, it is much less obvious, and we may have no idea how much energy we are truly consuming. It is therefore important that we can measure energy to get a better understanding of how much energy is used and how it can be saved. To measure energy, we first need to define its units. For this, we use the joule. 1 joule is a very, very tiny amount of energy, and so energy is often discussed in terms of millions of joules, also known as megajoules. To give you an idea of scale, a megajoule is about the same amount of energy that is in a chocolate bar, so that's still a relatively modest amount. The total energy that we need as a person for a day is about 6 times as much. For comparison, 1 liter of gasoline is 33 megajoules. Now, before we continue, it is worth going over some common mathematical prefixes to avoid any confusion. The most common ones can be seen here. If you aren't familiar with these, it would be useful to try and commit them to memory. Which prefixes are used, of course, depends largely on the scale at which we are looking. The annual energy use of households is measured in gigajoules, but for a country it is rather in petajoules. Next, we need to make the important distinction between energy and power. In the Energy Slaves video, it is explained that if you have a shower, for instance, then there is a huge amount of power consumption. Power is the amount of energy that is delivered at a specific moment in time. But we only shower during a limited period. So although showering has a high power consumption, the total energy consumption can still be quite limited if you only draw the power for a short amount of time. Accordingly, there is a relationship between power and energy. Energy use is power consumption times the time you use the power. This equation can be rearranged to show that power is energy divided by time. The unit of energy is a joule, and so the unit of power is joules per second, also known as watts. It's very important not to mix up the two. Let me now introduce another well-known unit of energy, and that is the kilowatt hour. As we saw in the last slide, if you use 1 watt of power, this means you use 1 joule per second. If you use 1 kilowatt, which is 1000 watts, then you are using 1000 joules per second. As you can see, the relation is quite straightforward. 1 kilowatt hour means you are using 1 kilowatt for 1 hour, meaning 1000 joules per second for 3600 seconds. The total energy content of a kilowatt hour is therefore 1000 times 3600, which is 3,600,000 joules, or 3.6 megajoules. Thankfully, you will not have to repeat this equation every time you see this unit, provided you remember that 1 kilowatt hour is 3.6 megajoules. There is also the megawatt hour, which is 3.6 gigajoules. So in summary, the kilowatt hour is just another unit of energy. But let me also show why the kilowatt hour is such a convenient unit. Assume you have a laptop with a power consumption of 30 watts, and you want to know how much energy it has used over a year. And remember, energy is equal to power multiplied by time. We assume that every week you use the laptop for 20 hours and that it is used for 50 weeks per year. In total, it is therefore used for 1,000 hours per year. From here we can simply calculate the energy consumption. 30 watts times 1,000 hours equals 30,000 watt hours or 30 kilowatt hours. From this calculation we know that a laptop adds 30 kilowatt hours to your electricity consumption and ultimately to your electricity bill each year. There are various other units that are used to express quantities of energy. One is the barrel of oil. If you look at oil statistics and even the price of oil, these are all expressed in barrels. A barrel of oil is about 6 gigajoules. Another unit that is often used is the term ton of oil equivalent. A ton of oil is much more than a barrel of oil. It is equivalent to roughly 42 gigajoules. You find the precise conversion factor on this slide. There are yet more units, mostly derived from other fuels. For example, ton of coal equivalent or the cubic meter of natural gas equivalent. The same units can vary slightly in megajoule equivalent between countries due to differences in coal and natural gas qualities. But in general, let's stick to the regular units which are part of the SI system of units. You will find more information about each unit and also about a number of other energy units in the additional material after this video.